Hello there, and welcome back to the Sleep Science, your nightly escape into the weird, the wondrous, and the occasionally unsettling edges of our cosmic curiosity. Tonight, you're floating through the quiet hum of the universe's beginning, tethered only by a thin line of data and human wonder. The James Webb Space Telescope, JWST if you're on friendly terms, has opened its gilded petals to the dark, and you're about to drift through what it sees. The images it's captured aren't just beautiful, they're inconvenient, disobedient, and a little bit terrifying. You probably won't survive this, scientifically speaking. So before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. Let me know where you're listening from and what time it is where you are. Maybe it's past midnight. Maybe it's just after dawn. Either way, the light from your screen is about to compete with photons that have travelled over 13 billion years just to meet you. Now, dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. You begin where humanity left off, at the point where the Hubble Space Telescope grew old and weary. Hubble's mirror was sharp, but its eyes were limited. It saw mostly invisible light, catching stars and galaxies that were already formed, already comfortable. The Webb, though, the Webb doesn't care for comfort. It was built to peel back time itself, to read the faint whispers of the first starlight through the more long, stretched wavelengths of infrared. Think of it as seeing through cosmic fog, finding warmth where there should only be cold silence. You float beside it now at the second Lagrange point, L2 for the astronomically lazy, 1,000,000 miles from Earth. There, the telescope hovers in perfect balance, Earth and Sun pulling equally on its sides. Its massive golden hexagons gleam like a crown against black infinity, reflecting not sunlight but ambition. When it first unfolded, it was like watching origami done by a god, layer by layer, petal by petal, as if the universe itself leaned closer to see. Below you, engineers hold their breath. The telescope's mirrors align to within a fraction of a human hair. They murmur about wavefront error, thermal drift, and micrometeorite impacts. You murmur back a sleepy, good luck. Because once this thing looks up, it'll see farther than anything ever has. And seeing too far, as you're about to find out, comes with consequences. The first images Webb sends home are miracles wrapped in confusion. Galaxies spin like frozen fireworks. Nebulae breathe in veins of red and blue, and light from the earliest times floods through detectors so sensitive they could pick up the heat of a bumblebee on the moon. The Carina Nebula, the Southern Ring, Stephan's Quintet, all become instant desktop wallpapers and coffee table book covers. But underneath the celebration there's an unease brewing in the astrophysics community. Because Webb isn't just showing beauty, it's showing mistakes in our story of the universe. Historians still argue whether the launch of Webb in 2021 marked the beginning of a new scientific renaissance or the quiet start of cosmology's identity crisis. Never before had an instrument thrown this much light on the dark corners of existence. And light, as history shows, is often rude to the comfortable narratives we build. You drift closer to the telescope's primary mirror. It's so precisely polished that if it were stretched across Earth, its largest bump would be only a few centimeters tall. Its sensors hum with chilled precision, temperatures near absolute zero. Behind it, a 5-layer sunshield the size of a tennis court keeps it cool, paper-thin and fragile as the surface of a soap bubble. The shield is necessary. Even a hint of warmth would drown the faint signals Webb seeks. It's like trying to hear a whisper at the bottom of an ocean while standing in a hurricane. You can almost hear that whisper now, the ancient photons stretched thin by time finally arriving. Each one is a message from the past, carrying news older than Earth itself. One photon might have escaped a dying star in a primordial galaxy before our sun had even formed. Another might have left the swirling plasma of the early cosmos, long before atoms existed. They fall on Webb's sensors, silent travelers that have outlived everything they once touched. A quirky tidbit floats to mind. When those first photons began their journey, there were no planets, no metals, no life. The entire universe was just hydrogen, helium, and darkness. Yet here they are, ending their journey inside a machine built by creatures who evolved from dust. If cosmic irony had a punchline, this would be it. The first public release of Webb's deep field image hits humanity like caffeine to the soul. You remember it, the patch of sky so small you could cover it with a grain of sand held at arm's length. And yet within that speck, thousands of galaxies, each one containing billions of stars. It's a photograph of infinity crammed into a frame. Astronomers blink, then frown, because some of those galaxies look too mature, too structured, too wrong. You watch their data scroll across monitors, numbers flowing like a digital heartbeat. Some galaxies appear to have formed only a few 100 million years after the Big Bang, when the universe was supposed to be too chaotic for such neat spiral structures. That shouldn't be possible. Either the universe grew up faster than we thought, one scientist mutters, or our math did. Another jokes nervously that maybe the telescope accidentally looked into the future. As you drift along Webb's line of sight, you feel the weight of that idea. Looking too far might mean seeing something not meant to be seen yet. It's like reading ahead in a cosmic script still being written. A historical note hums through your sleepy thoughts. When Galileo first turned his telescope toward Jupiter, he saw moons, proof that not everything revolved around Earth. It shattered centuries of belief in one glance. Webb might be doing the same, only on a scale that makes Galileo's rebellion look like a child's telescope pointed at a street lamp. You glance once more into that endless mosaic of galaxies. Their light is faint but defiant, a testimony to something beyond our comprehension. Each glimmer is both a relic and a warning. Humanity wanted to see the beginning, and Webb, obedient and brilliant, has shown it. But the beginning doesn't look like what we expected. Out here in the silent dark, you can't shake the feeling that the telescope's golden eyes aren't just looking out, they're looking back. You're still adrift beside that glimmering insect-like machine, but the ore has started to morph into something quieter, heavier. The data keeps arriving in endless streams, and humanity is beginning to realize it may have built a device that's too good at its job. The James Webb Space Telescope is showing the first light that shouldn't exist. Galaxies are appearing where no galaxies should be. Bright, structured, confident little overachievers, shining less than 400 million years after the Big Bang. According to textbooks, that's roughly when the cosmic toddler stage should have begun, hydrogen clouds stumbling toward the idea of stars. But Webb's pictures look more like the universe in full adulthood, politely ignoring our schedules. You peer at one of these ancient galaxies, just a smudge in the telescope's field of view, but bright enough to compete with modern ones. It's labelled GLASS-z13, a name about as poetic as a filing code. Scientists estimate it's 13.4 billion light-years away. The number alone should make your neurons twitch. The light hitting the telescope's detectors left that galaxy when the universe was only about 3% of its current age. And yet, in those photons lies structure. Spiral hints, possible star clusters, maybe even dust from exploded stars. Dust means previous generations of stars already lived and died, which means, well, the universe was busier, earlier than anyone thought. You picture cosmologists leaning over their laptops, rubbing their eyes like exhausted detectives. These galaxies are too massive, too soon, one whispers. Another taps the redshift data, numbers that describe how much the universe's expansion has stretched the light. If the math is right, she says, then our entire model of galaxy formation might be wrong. Historians still argue whether that sentence marked the start of a revolution or just an uncomfortable phase, but either way, nobody's sleeping well at NASA this week. You drift deeper into Webb's first deep field image, tracing the faintest smudges. Every pixel represents something that shouldn't yet be. The colours, shifted into visible tones from infrared data, look almost painterly. Rust reds, phantom blues, soft gold halos. But you know those shades aren't just pretty. They're time translated into vision. Each hue is a code for temperature, age, and motion. The brighter the glow, the faster your pulse seems to sync with it, as if the cosmos itself has a heartbeat that's just a few billion years out of phase with yours. Here's a quirky tidbit that feels almost like cosmic humour. Some of the light Webb detects was once microwave radiation, stretched so far by the expansion of the universe that it's now barely above absolute zero. Yet somehow it's still here. Proof that time doesn't erase, it just hides. That means when you look at those galaxies, you're technically bathing in ghost light, photons that have outlasted stars, planets, and entire epochs of creation. Romantic, sure, but also deeply unnerving. You can imagine the first public reaction to Webb's findings. Scientists expected tiny, chaotic blobs. Instead, they got elegant galaxies forming way too fast. One astronomer likened it to the finding a fully grown tree in a field where the seeds were just planted yesterday. The analogy sticks in your head as you float past another galactic cluster. Is light older than continents, older than atoms in your bones? Then comes the truly disturbing part. The brightness of these early galaxies implies they contain far more mass than they're supposed to. If that's true, they might have formed through mechanisms no one has even hypothesized. Maybe dark matter worked differently back then, maybe physics itself did, or maybe, just maybe, the early universe wasn't as early as we think. You can practically hear the late-night debates echoing across observatories. Did Webb break cosmology? Are we misreading redshift? Has the speed of light always been constant? That question feels like a pebble tossed into an ocean of existential dread. It reminds you of another historical moment, back in the 1920s, when Edwin Hubble discovered that galaxies were moving away from each other, proving the universe was expanding. Before that, most scientists thought the cosmos was static, eternal. The revelation was shocking then. Webb's might be its modern twin. Both telescopes named for men who couldn't have imagined the cosmic trouble they'd unleash. You drift closer to one of those impossible galaxies, the infrared glow humming like a slow heartbeat. You can almost picture its first stars, massive and blue, burning with 1,000-fold intensity of our sun. They would have lived brief, furious lives, maybe a few million years, before collapsing into black holes or scattering heavier elements into space. Those elements, oxygen, carbon, iron, would one day form everything from meteorites to blood cells. And here's the eerie part. Webb is catching their fingerprints. In one spectral reading, you spot something absurdly familiar. Oxygen lines, possibly even signs of early water vapor. Water. In a universe still figuring out how to make stars. It's the cosmic equivalent of finding a skyscraper in the middle of a campsite. Scientists blink, recheck calibration, and eventually agree the signals are real. Historians still argue whether these are genuine primordial chemical signatures or the result of cosmic dust trickery, but either way, it means the ingredients for life were mixed into the recipe almost immediately after the cosmic kitchen opened. It's funny, in a dark sort of way. For centuries, people thought of the early universe as empty and violent, a long, cold prelude before the grand crescendo of life. But Webb's photos make it look lush, fertile, almost eager. You can't help but feel a twinge of unease at that eagerness, like walking into a garden that's grown a little too fast, a little too perfectly, while you weren't looking. And here's your first small joke of the night. One astrophysicist on social media quipped, "If galaxies formed this early, maybe the universe just skipped tutorial mode." You smile, but it doesn't fully land, because part of you suspects the punchline might be serious. Maybe the cosmos didn't need a tutorial because it's done this before. The telescope continues its vigil. Each week brings new press releases, new deep field mosaics, and new contradictions. You can almost hear Webb whispering through the data stream. You wanted to see everything, and now you do. Humanity gazes into the earliest light, and instead of simplicity, it finds complexity. Instead of beginnings, it finds echoes. Somewhere between those paradoxes lies a truth that no one's ready to face yet. The light that shouldn't exist is real. It's out there, gleaming defiantly against the rules. And as you hover beside the golden mirrors, you realize something uncomfortable. If the universe is already older and stranger than we thought, then maybe, just maybe, so are we. You drift a little farther from Webb now, watching as its gold mirrors tilt like a sunflower following invisible light. The telescope is whispering across time, not in colours your eyes can see, but in stretched out wavelengths, infrared, the language of heat and distance and ghosts. Through this lens, you're not looking at the universe as it is, you're looking at what it was billions of years ago. The phrase time travel through infrared eyes isn't poetry, it's physics. You're seeing the past in real time, and that simple fact might be the strangest magic humanity has ever pulled off. The airless quiet of space vibrates with photons that left their homes when the cosmos was still molten with creation. You imagine them as messengers, each one a delicate survivor of a journey so long that it can't truly be measured. When Webb's sensors catch them, they're already ancient, worn thin, stretched by the relentless expansion of the universe. The infrared spectrum turns that tired light into something visible again, translating age into warmth, It's like finding an old love letter that's been erased and rewritten 1,000 times, and still, somehow, it speaks. One of Webb's earliest triumphs, an image called GLASS-z13, shows a galaxy cluster acting as a gravitational lens. The cluster's immense mass bends light like glass, pulling distant galaxies into elongated arcs. It's nature's telescope magnifying the oldest things that exist. Historians still argue whether Einstein could have imagined such a direct, luminous demonstration of his relativity equations. Probably not. He once called the idea of an expanding universe abhorrent, and yet here you are, floating through his abhorrence turned revelation. As you drift through the glowing arcs of SMACS 0723, a flicker catches your attention. Something faint, something odd. Webb's detectors register a signal deeper than expected, a reddish smear of light behind the cluster. Scientists initially dismiss it as noise, a glitch in calibration, but repeated exposures show it's no glitch. It's a galaxy farther than any galaxy seen before. Its light began travelling when the universe was just a few 100 million years old, when matter itself was learning how to become structure. The name they give it, CEERS-93316, sounds bureaucratic, but its implications are not. It shouldn't be there. Its mass, its brightness, its apparent age, all suggest it matured impossibly fast. You feel an echo of the earlier unease returning. Every new discovery seems to sharpen that paradox. The farther Webb looks, the more mature the cosmos appears. Either the timeline is wrong or the physics are. You imagine the control room at NASA when the anomaly first appears. Screens filled with spectra, those rainbow fingerprints of starlight, telling scientists what elements the galaxy contains. Hydrogen, of course, helium naturally, but then oxygen, carbon, even hints of heavier metals. These are the byproducts of multiple generations of stars, meaning there must have been earlier suns that lived, died, and scattered their ashes. How could so much have happened so quickly after the supposed beginning? A quirky fact surfaces while you ponder this. The term infrared was coined in 1800 by astronomer William Herschel when he discovered invisible heat rays beyond red light. He realized that color was just temperature disguised as hue. Now, 2 centuries later, you're using the same principle to see back almost to the dawn of existence. Herschel's prism experiment feels quaint compared to Webb's unfolding origami in space, but the spirit is the same. A curiosity that refuses to mind its own business. Webb's infrared sensors are miracles of engineering, each one cooled to just a few degrees above absolute zero, so faint heat from the telescope itself won't drown the cosmic whispers it's listening for. You can picture it now, sunshield's stretched wide mirror glittering deep in the cosmic night. It's more than a telescope, it's a time machine made of gold and anxiety. Every photon it catches is an accusation. You thought you understood me, but you don't. You drift closer to one of those red-shifted galaxies. The light is faint but pure, a syrupy glow you can almost taste. The data says it's 13.5 billion years old, but there's a flicker in the spectral readings, something that doesn't match known templates. It could be a calibration error or something stranger. The analysts hesitate to publish. Historians still argue whether that hesitation was caution or fear. After all, each Webb image is both discovery and disruption. The telescope is rewriting cosmic history one exposure at a time, and the ink is still wet. To grasp what is happening, you remind yourself of a simple but mind-bending truth. When you look at distant light, you're looking through expanding space. The farther away something is, the faster it moves away from you, stretching its light toward red. That's why Webb's infrared vision is so crucial. It can see what Hubble couldn't. But there's a limit to that clarity. Past a certain distance, light becomes so stretched that it blends into the background radiation, the echo of the Big Bang itself. Webb dances right on that edge, staring into the twilight between creation and unknowable. You recall another moment in science history, in 1995, when Arno Penzias and Robert Wilson accidentally discovered the cosmic microwave background, radiation from the birth of the universe, while trying to remove pigeon droppings from their antenna. That faint hiss confirmed the Big Bang theory. Webb, decades later, isn't just confirming, it's challenging. If galaxies existed too soon, maybe the Big Bang wasn't as clean or singular as we've been taught. Maybe creation was messy, recursive, maybe it began more than once, You can't help but smirk at the thought. Somewhere, an astrophysicist is weeping into their coffee while another is ordering champagne. Science thrives on confusion, but this is chaos on a galactic scale. The universe is trolling us, one researcher jokes during a live stream, earning nervous laughter from the chat. It's funny because it's true. You zoom out, letting the cosmic scene expand before you. The red arcs, the mirrored galaxies, the improbable clusters, all stitched together like a tapestry woven by a dimension that didn't get the memo about human timelines. Webb stares, patient and unblinking, and the universe stares back, amused. Maybe that's the quiet horror of it all. For the first time, humanity built something capable of seeing not just where we came from, but how little we actually know about the path. The more light Webb gathers, the darker the questions become. You feel it now, the uneasy thrill of discovery, the vertigo of peering too far into the past and realizing it looks uncomfortably familiar. Because maybe, just maybe, what Webb is really showing us isn't how the universe began. Maybe it's showing us that it never truly did. You float beside the glowing honeycomb of Webb's mirrors, and tonight they're staring into regions of the sky that have no business being so bright. The telescope's infrared eyes are tuned toward galaxies that refuse to obey any of the polite rules astronomers spent a century building. The data streaming back shows star systems that are too massive, too mature, too beautifully formed for their age. It's like walking into a nursery and finding toddlers filing taxes and discussing mortgages. You zero in on one of them, CEERS-93316, a compact spiral sitting 13 billion light-years away. The swirl of its arms gleams with the light of billions of suns. According to theory, galaxies at that age should look like smudges, shapeless and chaotic, built from clouds that hadn't yet learned discipline. But this one looks like it's been practicing for eons. Historians still argue whether the early interpretations of these structures were just overexcited pixel chasing or genuine glimpses of ancient order. Either way, the embarrassment in the astrophysics community is palpable. The early universe, it seems, was not the messy, stumbling child they'd imagined. It was precocious. You remember one late-night press conference where a researcher nervously laughed and said, "It's as if the universe went from crawling to calculus overnight." The audience chuckled. But the silence afterward was the kind that only happens when people start wondering whether they're wrong on a fundamental level. Webb's sensors have a cruel precision. They don't just show shapes, they reveal composition, temperature, and movement. When scientists measured the rotation speeds of these early galaxies, they found something unsettling. Many were spinning as quickly and evenly as the Milky Way does now. That level of organization should take billions of years of cosmic evolution. Yet there it is, happening when the universe was barely out of its cosmic cradle. A quirky historical note drifts through your mind. In the 1920s, Hubble categorized galaxies by shape, spirals, ellipticals, irregulars, creating what he called the tuning fork diagram. Back then, it seemed logical that galaxies matured through those forms, starting as irregular blobs and slowly refining themselves. Webb's discoveries have snapped that tuning fork clean in half. Some of the earliest galaxies are already spirals, while others are so large they make our Milky Way look like a side project. Hubble gave us order, Webb delivers anarchy. You glide deeper into the data cloud, where simulated reconstructions turn those faint blips into luminous three-dimensional forms. Gas swirls like slow lightning. Stars ignite in clusters so dense they resemble cosmic cities seen from orbit. It's breathtaking, but it also feels wrong, as if you're witnessing a rehearsal for a play that somehow came before its script. The universe is supposed to start simple and grow complicated, yet what you're seeing suggests complexity was there from the beginning. Some researchers offer comforting explanations. Maybe we've misjudged the distances, they say. Maybe gravitational lensing, where massive objects bend and amplify light, makes these galaxies look closer and brighter than they truly are. It's possible, but not probable. Webb's instruments are designed to account for lensing distortions. Others whisper about new physics, altered dark energy behavior, exotic inflation models, variable light speed. You can practically hear the whiteboard squealing with fresh equations. Historians still argue whether this era, the first few months of Webb's discoveries, marks the great recalibration of cosmology. Never before had so much precise data arrived so quickly. Theorists raced to keep up, rewriting models weekly. Some even proposed the possibility that the Big Bang wasn't a singular event at all, but one in a chain of cosmic pulses. each universe giving birth to the next like bubbles in boiling water. It's poetic, terrifying, and deeply inconvenient. You let your attention wander to the colour composites displayed across mission screens. There's something eerily human about them. Those spirals and arcs, their delicate filaments like fingerprints pressed against glass. Each galaxy a signature, each cluster a sentence in a story that might not end with us. Here's your first wry joke of the evening. One astrophysicist on a podcast sighed and said, "We asked the universe how it started, and it basically replied, 'None of your business.'" The line went viral because it was too accurate to dismiss. For all our telescopes and theories, Webb has reminded humanity of a painful truth. We're toddlers with crayons trying to redraw creation. But the confusion isn't just theoretical. These early galaxies pose a logistical nightmare. To form so much mass so early, they'd need to convert gas into stars with near-perfect efficiency. That's statistically absurd. It's like flipping a coin 1,000,000,000,000 times and getting heads every time. So scientists begin inventing new cosmic recipes. Super-efficient star formation, exotic cooling mechanisms, dark matter scaffolding that pulls atoms together faster than gravity should allow. Yet every new fix raises a new contradiction. The data refuses to sit still. You float past another structure, a cluster where dozens of galaxies seem bound together by invisible threads. The gravitational modelers say they shouldn't have had time to merge, and yet there they are, waltzing in perfect synchrony. It's as if someone skipped ahead in the cosmic script and handed them choreography notes. It reminds you of another moment in scientific humility, when we first discovered exoplanets in the 1980s. The earliest detections were gas giants hugging their stars, hot Jupiters, which no model predicted. Everyone thought the instruments were broken. They weren't. We just hadn't imagined nature being so creative. Webb is doing the same thing now, only this time it's not just planets, it's the entire timeline of existence. You drift farther, tracing faint arcs of light that curve like fingerprints pressed into the cosmic background. The silence is deceptive. Somewhere, countless scientists are rerunning simulations, adjusting constants, arguing in conference calls that last until dawn. Maybe galaxies just cheat, one jokes, earning hollow laughter. You look again at those ancient spirals, those impossible jewels spinning calmly against the velvet dark. For a moment, you forget to breathe. Then the thought hits. Perhaps the universe isn't misbehaving. Perhaps it's us who arrived late to the story, reading chapter 1 as if it were the prologue. Because if the cosmos began this organized, this eager, then the rules we live by, the ones about time, entropy, and growth, might only apply locally. Somewhere out there in those elegant swirls of premature starlight lies a truth older than beginnings. And as Webb's golden mirrors catch yet another impossible glimmer, you realize that for all our equations and arrogance, the universe was never obliged to make sense. You hover in the cold dark, staring at the screen where Webb's newest composite blooms like spilled ink across the cosmos. The deeper the telescope looks, the stranger the light behaves. This is the realm of gravitational lensing, the cosmic mirage problem. Galaxies curve space itself with their mass, bending light from anything behind them. It's beautiful in theory and infuriating in practice because it means you can never quite trust what you're seeing. Every elegant spiral or ghostly arc might be real, or it might just be a trick of geometry stretched thin by time. You watch as the light from a distant galaxy takes a 13 billion year detour, looping around an invisible mass before finally hitting Webb's sensors. It's the ultimate photobomb, the universe capturing its own reflection. Einstein predicted this over a century ago, long before telescopes could even dream of catching it. Historians still argue whether he truly believed such distortions would ever be observed, or if it was one of those theoretically possible but practically ridiculous kind of ideas. Either way, Webb now uses these cosmic mirages as natural magnifying glasses, seeing even deeper into time by peering through the warped light of the nearer universe. The effect is intoxicating. You drift past a cluster called Abell 274, nicknamed Pandora's Cluster for good reason. Massive galaxies sit in its heart, their gravity bending space-time like a funhouse mirror. Behind them, Webb detects faint smudges of light, galaxies so distant they appear several times over, duplicated by the curvature. Some form perfect circles known as Einstein rings, others stretch into surreal ribbons that look more like brush strokes than stars. It's dizzying. You start to wonder if any of the galaxies in view are real in the ordinary sense, or if you're just seeing echoes, reflections of something far beyond the cluster, multiplied like whispers in a canyon. A quirky little fact to keep you anchored: the first confirmed gravitational lens wasn't seen until 1979, when two nearly identical quasars were discovered in the sky. At first, astronomers thought they'd found cosmic twins, but later realised they were looking at one object duplicated by warped space. That discovery was thrilling. Webb's view makes it look quaint. Instead of two copies, the telescope sometimes sees dozens, mirror universes of the same galaxy, shimmering around invisible centres of mass. But the beauty hides a problem. When everything is bent, stretched and reflected, how can you tell how far away anything really is? The entire cosmic distance ladder, the careful method of measuring how light dims with distance, starts to wobble like a bad table leg. Some of the ancient galaxies might not be ancient at all. They could be normal ones, just magnified and reddened by lensing. Others truly might be primordial, the first bursts of starlight from the dawn of everything. Sorting truth from illusion has become the new obsession of cosmology. You watch a team of researchers debating on a late-night stream, their voices alternating between excitement and exhaustion. "We're playing detective," one says, tracing arcs on a map of Able 274. "Every piece of light is a clue, but the culprit keeps changing shape." The others laugh quietly, though not with much confidence. Another mutters, "Maybe the universe just likes puzzles." Historians still argue whether Webb's reliance on gravitational lensing is genius or madness. It's like trying to study a city by looking only at its reflections in water. Every improvement in clarity reveals new distortions. The telescope gives answers wrapped in riddles, and for every galaxy discovered, two more appear behind it, ghostly, taunting, unreal. You drift along one of those glowing arcs. The light here is older than bones, older than any concept of seeing. It's been twisted through billions of years of gravitational turbulence. And yet it still holds together. That resilience feels personal somehow, proof that even distorted truths can carry meaning. You reach out, fingertips brushing the imagined light, and wonder whether the galaxy it came from still exists. Maybe it burned out long ago, its stars now ash and dust. What you're seeing is not its presence, but its echo projected forward by the curvature of space-time. The universe doesn't just preserve memory, it weaponizes it. There's a strange comfort in realizing that even false images have purpose. Lensing lets scientists glimpse regions far beyond Webb's normal range, revealing galaxies that would otherwise remain invisible. But it also fuels a new anxiety. If space-time itself can lie, then how many of our cosmic conclusions are built on optical illusions? One researcher jokes, "We're archaeologists digging in a hall of mirrors, and you can't decide whether to laugh or shiver, make sense of it all. Teams build intricate computer models that attempt to reverse the lensing, mathematically unbending the light to reconstruct what's really there. It's meticulous, almost surgical work. Each cluster's mass distribution must be mapped, each photon's path retraced. But even then, the reconstructions differ slightly depending on assumptions. One version shows a galaxy the size of Andromeda, another, a fragment no bigger than a dwarf satellite. The truth, as usual, hides between them. A historical echo whispers again. Back in the Renaissance, mapmakers argued over whether Earth's continents were properly drawn, each distortion changing how explorers imagined the world. Webb's lensing maps feel like those antique globes, beautifully wrong in all the right ways. You can sense the same mixture of arrogance and awe that once drove sailors to cross oceans without knowing where they'd end up. Your own gaze drifts to the faintest edges of the field, where arcs fade into black. There, the distortion's thin, and you glimpse something almost undistorted, a tiny ancient glow. For a heartbeat, you feel as though you're looking directly at the universe before it learned to trick itself. Then the data flickers, recalibrates, and the mirage swallows it whole. Maybe that's the real lesson of lensing. Every truth in the cosmos arrives bent, delayed, filtered through gravity's strange humour. Even the purest light carries the fingerprints of everything it passed. The Webb isn't showing us just where galaxies are, it's showing us how reality itself curves under the weight of its own memory. You drift back toward the telescope, its golden mirrors glinting faintly. Somewhere inside, sensors are catching more of those distorted photons one by one, translating illusion into understanding. You can almost hear the whisper behind it all. Don't trust what you see, trust that you're seeing something worth doubting. You float through a patch of the universe that should be full of invisible scaffolding. Dark matter, the mysterious glue that supposedly holds everything together. For decades, cosmologists built entire careers around the idea that galaxies couldn't form without it. Ordinary matter, the kind that makes up stars, planets, and you, is only about 5% of the cosmos. The rest is this unseen web of gravity we can't touch, taste, or detect directly. But as Webb peers farther and deeper, it begins to expose something unsettling. In some of its earliest images, galaxies appear to be forming without enough dark matter to explain their existence. The invisible glue might not be there after all, or it's doing something we've never seen before. You look at a cluster designated MAX 149 in JD1, one of the first distant galaxies Webb observed. By mapping how its light bends through space, astronomers can estimate the gravitational pull around it. But the numbers don't add up. There's not enough gravitational lensing for the supposed amount of dark matter that should be there. It's as though the cosmic skeleton has a few missing bones. Historians still argue whether this means Webb has revealed a flaw in our models, or if dark matter simply behaves differently in the universe's youth, denser, smoother, or more slippery. Whatever the truth, it's throwing a wrench into the cosmological machine. You picture a group of physicists huddled in a control room at 2 a.m, eyes bleary, coffee cups empty. One murmurs, maybe dark matter clumped later. Another sighs, or maybe we've been chasing a ghost. It's the kind of quiet panic that only happens when reality refuses to cooperate. A few start running alternative models, modified gravity, cold dark energy, even ideas that suggest dark matter might decay over time. The equations glitter across their screens like constellations of confusion. A quirky tidbit bubbles to the surface of your mind. The name dark matter was coined in the 1930s by Swiss astronomer Fritz Zwicky, who noticed galaxies in a cluster moving too fast to be held together by visible mass alone. He called the missing mass-dunkel materia dark matter because, well, it sounded spooky and nobody could see it. Decades later, we're still haunted by his ghostly placeholder. Webb's findings aren't disproving Zwicky's idea, but they're bending it into strange new shapes. Some galaxies seem to have too much dark matter, others none at all. You drift past an image of the galaxy cluster SMACS 0723 again, remembering its elegant distortions. Behind it, a string of faint red dots catches Webb's eye. Each dot is a baby galaxy in the act of becoming. They appear to be forming stars faster than dark matter models allow. That shouldn't be possible. Gravity alone shouldn't have pulled enough ordinary gas together without dark matter's help. It's like baking bread with no yeast and somehow ending up with a perfect loaf. Historians still argue whether this discrepancy is just a measurement problem or a full-blown cosmological crisis. Either way, scientists are nervously rewriting the margins of the universe. If dark matter isn't behaving as expected, then every model of galactic formation, every simulation we've ever trusted, might need a cosmic patch update. One researcher jokes, maybe the universe didn't read our textbooks. The laughter that follows sounds like denial in stereo. You zoom closer to one of the so-called dark matter light galaxies. Its stars are bright and orderly, swirling around an invisible center, yet the gravitational data says there's barely enough mass to keep it from flying apart. You can almost feel the tension in that contradiction, like a violin string pulled too tight. How can something so fragile persist for billions of years? Perhaps gravity itself plays by different rules at cosmic dawn. Maybe the fabric of space-time was thicker then, more elastic. Or maybe, just maybe, dark matter was never the hero we thought it was. A ripple of memory reminds you of another historical upset, the late 1600s, when Isaac Newton first described gravity as a universal law. It explained everything beautifully, until Einstein came along 2 centuries later and bent it into relativity. History, it seems, loves to replace certainties with upgrades. Now Webb might be nudging us toward yet another rewrite. The laws that explain how stars cluster, how galaxies spin, how the cosmos holds itself together, all might need revisiting. The weirdest twist of all, some researchers think dark matter could be self-interacting, meaning it might occasionally collide or clump with itself instead of just passing silently through everything. If that's true, then early galaxies might have formed more quickly because dark matter was busier back then, sticky, cooperative, almost sociable. You can't help but smile at the thought of invisible particles shaking hands across time, but not everyone's amused. A small but vocal camp of scientists argues that dark matter never existed at all, that it's just a mathematical crutch for our incomplete understanding of gravity. Their theory, called MO-ND, modified Newtonian dynamics, suggests that gravity itself just changes behaviour at extremely low accelerations, such as the edges of galaxies. Webb's data frustratingly gives both sides enough evidence to claim victory. The telescope has become an intergalactic Rorschach test. Everyone sees what they want and no one sees everything. You drift back toward the telescope, its polished mirrors glowing faintly under the cold light of distant suns. Inside, the instruments keep humming, converting invisible wavelengths into digital poetry. Somewhere another line of code flags another anomaly. You feel the weight of that word, anomaly, a polite way of saying we don't know what's going on. And here's your evening's small joke. One exasperated astrophysicist once tweeted, "Dark matter is like my car keys, always missing when I need it most." The post went viral among scientists who'd rather laugh than cry. You look once more into the depths Webb has revealed. The galaxies don't care about our confusion. They spin anyway, serene and self-assured. Maybe that's the real message hiding in the data. The universe works, even when our explanations don't. The cosmos doesn't wait for us to understand, it just keeps doing whatever impossible thing it was doing before we showed up with our equations. So you let yourself drift, watching the starlight ripple like distant waves, and think that perhaps dark matter's greatest trick isn't its invisibility. It's the way it forces us to admit again and again that we might not be the smartest thing in the dark. The light that reaches you now is full of secrets. Every colour, every spectral line Webb records carries a chemical confession, a story of what the universe was made of and when. You float beside the telescope's mirror, watching as data streams back in elegant ribbons of code. Each spike and dip in those spectral graphs represents an element: hydrogen, helium, oxygen, carbon, and in the early Webb results, those fingerprints begin appearing far too soon. The universe, it seems, has been lying about its age. According to the Standard Model, the first generation of stars, population 3, as they are romantically known, should have been pure hydrogen and helium. Heavier elements, what astronomers call metals, were supposed to appear only after those first stars lived fast and died explosively, enriching the next generation with carbon and oxygen. But Webb's spectrographs disagree. The telescope is finding galaxies glowing with the chemical signatures of maturity: oxygen lines, water vapor trees, even silicates, just a few 100 million years after the Big Bang. That shouldn't be possible. The cosmic kitchen had barely preheated, and yet the ingredients for planets and life were already simmering. You picture the scientists hunched over their screens, rechecking calibration again and again. It can't be oxygen, one mutters, it's too early, but the lines remain. Historians still argue whether those first spectral readings were truly revolutionary or just misinterpreted noise from interstellar dust. Either way, the unease stuck. If oxygen and carbon existed that early, the universe was far more efficient at cooking itself than anyone imagined. Here's a quirky little historical echo. In 1814, a German glassmaker named Joseph Fraunhofer first noticed dark lines crossing the sun's spectrum. He had no idea they were fingerprints of elements. 2 centuries later, Webb is doing the same trick across the entire universe, reading the atomic barcodes of galaxies older than imagination. You can almost sense Fraunhofer's ghost peering over your shoulder, astonished at what his simple prism had become. One of Webb's strangest discoveries comes from the galaxy Jade's GLASS-z13, whose light began its journey when the universe was only 320 million years old. Its spectrum reveals not just hydrogen but carbon and neon, elements forged in the hearts of dying stars. That means several generations of stars must have lived and died before this galaxy even formed. But there shouldn't have been enough time for that cosmic recycling. It's like walking into a brand new apartment and finding a stack of old family photo albums already on the shelves. You hover beside the data feed, watching new spectra flash on screen, each one a secret whispered across eternity. Webb's detectors are so sensitive they can detect a single photon of infrared light every few seconds. Those photons have stretched over billions of years, their wavelengths elongated by cosmic expansion. They arrive tired, red-shifted, and ancient, and yet they still carry the same elemental information they did at birth. You think of them as time capsules, light that left a star long before the Milky Way even existed, now gently bumping into a sensor made by hands that evolved on one of its descendants. Then the real twist appears. In several of these galaxies, Webb detects signs of water vapour. Not oceans, of course, but molecular water floating in interstellar clouds. That's impossible according to old models. Water needs oxygen, and oxygen needs at least one generation of stars to die first. So either the universe was making stars faster than we thought, or it had a head start. Some theorists whisper about cosmic pre-enrichment, the idea that the Big Bang itself might have seeded trace-heavy elements. It's fringe, even heretical, but the data makes heresy look oddly reasonable. A lively debate sparks across universities and message boards. Maybe dust contamination, one camp insists. Maybe new physics, another replies. You imagine the late-night Slack messages, the blurry Zoom calls, the hushed wonder when someone admits, "It's beautiful, but it breaks everything." Historians still argue whether these moments mark the end of cosmology as we know it or its true beginning. And amid the chaos, there's humour. One weary researcher tweets, "We looked for cosmic purity and found pollution instead." The post gets 100,000 likes because everyone feels the same bittersweet thrill. The early universe wasn't sterile and simple, it was messy, lively, and chemically impatient. You drift farther into that chemical fog thinking about the implications. If water existed this early, then maybe planets could too. If carbon and oxygen were abundant, then the ingredients for life, amino acids, sugars, all the chemistry that defines us, might have had billions of extra years to get started. Maybe we aren't the universe's first experiment in awareness. Maybe we're just the most recent. A memory surfaces of another cosmic surprise. In the 1950s, scientists discovered organic molecules floating in interstellar space. Glycine, formaldehyde, even alcohol. Back then, people thought space was sterile. Suddenly, it smelled faintly of gin and burnt sugar. Webb's data continues that legacy of cosmic intoxication. The universe, it seems, has always had a taste for chemistry that looks suspiciously like life. You glance again at the spectral lines glowing across the monitor. Each one represents an element that shouldn't be there yet. It's as if the cosmos has been caught skipping ahead in its own timeline. Maybe, one physicist jokes, the universe was in a hurry to evolve sentient life so it could finally be observed. Everyone laughs, but the silence afterward lingers longer than the humour. Because if the universe was already making the ingredients for life within its first heartbeat, then our presence here might not be a miracle of timing. It might be inevitable. You watch the redshift graphs fade into darkness, feeling the quiet awe of that realization. The Webb doesn't just show us ancient light, it shows us that the universe has always been suspiciously alive. And as the telescope keeps gazing deeper, translating invisible wavelengths into colour, you can't shake the feeling that somewhere out there, long before Earth, someone or something else might have already looked back. You drift alongside Webb's field of view as its golden mirrors tilt again, now pointed towards something even darker and hungrier than before. The telescope isn't just hunting galaxies anymore, it's listening for the echoes of monsters. What it finds makes even seasoned scientists fall silent. Supermassive black holes, already fully grown, sitting inside galaxies that shouldn't have existed yet. Their light, or more precisely their shadows, come from an age when the universe was barely 400 million years old. These are not newborns. These are ancient predators that somehow appeared before there was enough time to feed them. One of them stands out, a quasar labelled J0313-1806. When Webb locks onto it, the readings make no sense. It's powered by a black hole more than 1 billion times the mass of the Sun, yet it existed when the universe was still in its infancy. By every known rule of cosmic evolution, it should have taken billions of years for something that big to form. Historians still argue whether such early black holes could have started as the collapse of massive stars or as direct collapse giants, monsters born full-sized from collapsing clouds of primordial gas. Either way, the timeline doesn't fit. The universe's first monsters came too early to the party. You hover near the visualization feed as the data pours in. Webb's infrared instruments can't see the black holes themselves, of course, nothing can, but they can see the glow of gas and dust spiraling into them, heated to millions of degrees as it dies. Those emissions travel across billions of light years to reach Webb's detectors, faint, red, exhausted, yet still screaming. When the spectra are translated into visible colour, they look almost gentle, a warm blush around a cold heart. But you know better. You're staring into something that eats light for breakfast. A quirky historical tidbit floats to mind. The term black hole wasn't coined until 1977. Before that, physicists called them frozen stars, as if afraid to name them outright. Now they're practically celebrities, starring in documentaries and desktop wallpapers, but Webb's discoveries have turned them ominous again. These ancient behemoths aren't just curiosities, they're paradoxes. They suggest the universe might have been seeded with colossal gravitational wells from the start, like potholes in space-time left behind by something even older. Scientists try to explain it. Maybe these black holes formed from the collapse of gigantic clouds, 10,000 times the mass of our sun, that skipped the star phase entirely. Or maybe they started small but ate greedily, pulling in matter faster than theory allows. Either option breaks some cherished physical law. You picture a researcher staring at the screen, hair dishevelled, muttering, "If this is right, we're going to need a bigger universe." Historians still argue whether Webb's quasar data represents new physics or just extreme coincidence. But the numbers are relentless. One after another, Webb finds more of these early black holes. Some appear embedded in galaxies, others seem to float alone, surrounded by faint halos of ionized gas. And here's where it gets truly strange. A few of them show evidence of powerful jets, streams of particles launched at nearly the speed of light. To produce those, you need magnetic fields and structured accretion disks, systems that require time and complexity. Yet here they are, acting like veterans of cosmic engineering when the universe should still be tripping over its shoelaces. You lean closer, studying the faint glows. Each one represents a gravitational engine capable of reshaping galaxies. In fact, many scientists now think those early black holes helped sculpt the universe, blasting radiation that cleared away the cosmic fog and jump-started star formation. The irony is delicious. Creation born from destruction, light fostered by darkness. One physicist jokes, "The universe outsourced star formation to its local black holes," and the line earns a tired laugh, but beneath the laughter lies unease. If black holes this large existed so early, what created them? Were they remnants of something before the Big Bang? That's a question few dare to ask aloud, yet it lingers in every data meeting. Webb wasn't built to see before, but its discoveries are tempting people to imagine that maybe time has its seams, that something might have leaked through. You remember another historical moment when humanity faced such a leap. The day in 1919 when astronomers confirmed Einstein's prediction that starlight bends around the sun during an eclipse. Gravity wasn't just a force anymore, it was geometry itself, warping reality. Webb's data might be setting up a similar revolution. Instead of proving relativity, it's testing its limits. Some of these early black holes seem too efficient at bending light, as though gravity itself behaves differently in their vicinity. That's not supposed to happen, yet the evidence is stacking up like uninvited guests. A new theory starts whispering across research papers. Maybe these black holes aren't the result of matter collapsing inward, but rather gateways where energy from a previous universe condensed into our own. It's speculative and fringe, and beautifully absurd, just the kind of theory the universe loves to tease us with. You imagine some cosmic architect watching our confusion and chuckling softly. Here's your obligatory small joke. One astrophysicist during a press briefing sighed and said, "We built the world's most advanced telescope to look for baby stars and instead found billion-year-old caffeine addicts." The audience laughed, but there was nervous truth behind it. These ancient black holes behave like they've been awake since forever. As you float near Webb's shimmering form, the hum of its instruments feels like a pulse. Somewhere deep inside its databanks, more of these early quasars are waiting to be identified. Their light will take weeks to decode, their distances months to confirm, but you already sense the pattern forming. Wherever Webb looks deepest, something impossibly massive stares back. Maybe that's the true horror of these discoveries. The universe didn't start small and grow large. It may have begun with giants. And if black holes came first, if darkness preceded light, then perhaps the story of creation we've been telling ourselves is backward. The cosmos might not have begun with illumination bursting into the void. It might have begun with the void itself, quietly swallowing its own reflection until light learned how to escape. You watch Webb pivot toward another patch of ancient sky. Its mirrors gleam, and the faint, distant roar of collapsing matter hums through the vacuum. Somewhere beyond the edge of observation, a black hole older than time blinks open, waiting to be seen. You drift deeper into the cradle of ancient light, where the universe first began to glitter. The glow before you isn't from galaxies or quasars this time. It's from the first stars themselves, those elusive titans called Population 3. They are the holy grail of modern astronomy, the theoretical ancestors of every star that ever lived. Made entirely of hydrogen and helium, they burned hotter, brighter, and faster than anything that came after. Webb was built in part to find them, to witness the moment when darkness first learned to shine. But here's the twist: it hasn't. For months now, the telescope has been combing the early cosmos, zooming into pockets of time less than 200 million years after the Big Bang. According to models, these stars should be everywhere, massive solitary furnaces lighting up pristine clouds. And yet Webb's detectors keep finding the fingerprints of heavier elements instead. Oxygen, carbon, even more iron. The first stars, it seems, either died so quickly that their light is gone, or they were never as simple as we thought. Historians still argue whether Webb's silence is a failure of detection, or the first hint that our cosmic origin story needs a rewrite. You hover near the latest data stream, staring at a field nicknamed Cosmic Dawn. The telescope's sensors record tiny variations in colour, subtle shifts in infrared wavelength that hint at the temperature and size of ancient stars. Scientists expected to see clear, pure hydrogen signatures, but the lines are messy, overlapped, almost impatient. It's like trying to find the sound of a flute in the middle of a rock concert, one researcher sighs. Another adds, or maybe the flute never played. Here's a quirky historical note to anchor you. Back in 1868, astronomers studying the sun's spectrum found a mysterious yellow line they couldn't match to any element on Earth. They named it helium after the Greek god of the sun, Helios, discovered in space before it was ever found on Earth. Imagine their faces if they'd known that, billions of years earlier, the universe was filled with nothing but that gas. Population 3 stars should have been helium's first stage act, the cosmic orchestra tuning up before the grand performance. But Webb is catching the show halfway through, as if someone skipped the overture. The implications spiral outward like galaxies themselves. If those primordial stars truly are missing, then maybe something else lit up the cosmos. Perhaps black holes, the ones you saw earlier, did it first, flooding the darkness with energy from their accretion disks. Or maybe early dark matter structures gave off light through exotic processes we can barely imagine. Theories multiply like cosmic rabbits. You picture the late-night meetings at research institutes, the long tables, the coffee rings, the slide after slide of disappointing spectra. We should have seen them by now, someone mutters. Maybe they were bigger than we think, another replies, too massive to survive for long. Indeed, one popular idea suggests that Population 3 stars were so enormous, hundreds of times the sun's mass, that they lived only a few million years before exploding. Their deaths would have been spectacular supernovae that briefly outshone entire galaxies. The trouble is, even their corpses should leave clues: chemical scars, background radiation, faint ripples in the intergalactic medium. Webb has found none of them. You can almost hear the exasperation in a quote that went viral among astronomers. It's like opening a time capsule and finding it empty except for a note that says, "Nice try." The universe, as always, refuses to cooperate, and yet the mystery glows with a strange allure. If the first stars really have vanished without a trace, what does that mean? Did they burn so violently that their light was absorbed by the fog of neutral hydrogen before escaping? Or are we simply looking in the wrong place or wrong way for them? Webb sees in infrared, but perhaps those first stars shine in ultraviolet wavelengths stretched beyond even its reach. Some researchers have begun designing follow-up missions to chase the missing light, as though tracking ghosts through an ancient forest. Historians still argue whether this absence should be treated as evidence in itself. After all, science has a habit of finding truth in what isn't there. When astronomers noticed Mercury's orbit misbehaving in the 1800s, they invented a phantom planet called Vulcan to explain it. Only later did Einstein show that no such planet existed. Relativity alone accounted for the anomaly. Perhaps Population 3 stars are our modern Vulcan, a necessary myth to patch a gap in understanding. You lean closer to one of Webb's colour composites. It shows a faint cluster at redshift Z16, meaning it's light left when the universe was only about 250 million years old. The colours are false, mapped from infrared data, but they pulse with eerie beauty. Somewhere in that cluster, hidden or gone, the first stars may have burned themselves out before any eye could see them. You imagine them as titanic blue beacons, their light so intense it tore atoms apart, clearing paths for future generations. Without them, nothing, including you, would exist. Even in absence, they've left fingerprints on everything. Here's your small joke before the melancholy settles in. One researcher sighed during a conference call and said, "Maybe the first stars saw us coming and decided to ghost." Another replied, "Well, they had 100 million years head start." The laughter fades quickly, replaced by a quiet reverence. Because what Webb has really shown isn't failure, it's humility. The universe has layers we haven't yet peeled back, melodies we can't yet hear. Maybe the population of 3 stars are hiding just beyond the edge of detection, waiting for patience to catch up. Or maybe the cosmos began differently than our textbooks dare to suggest, less like a clean birth, more like a chaotic remix. You drift back from the telescope's gaze, eyes lingering on that faint, ghostly light. For all the missing stars, the darkness feels alive, expectant, like an audience holding its breath before the curtain rises, and you can't shake the sense that somewhere beyond the veil of Webb's infrared sight, the universe is smiling softly, whispering, "Keep looking." The deeper you drift into the Webb's mosaic of galaxies, the more you notice the spaces between them, the silent dark that stretches like glass between islands of light. Tonight, the telescope's gaze turns not toward the shining things, but toward the emptiness itself, the vast, echoing cavities called cosmic voids. They're not truly empty, of course. They contain a few lonely atoms per cubic meter, perhaps a smattering of dark matter, maybe even the faint whisper of ancient radiation. But compared to the crowded galaxy clusters that line the universe's filaments, these voids are deserts, immense, symmetrical, unnerving deserts. And Webb's latest images reveal that they may be far more structured than anyone expected. You stare at one of them, an enormous gap spanning nearly 1 billion light-years across, mapped not by stars but by absence. The galaxies around its edge form a near-perfect ring, as if sculpted by some invisible hand. Historians still argue whether the symmetry is coincidence or pattern. Scientists call it the Eridanus supervoid. Philosophers, predictably, prefer the Great Nothing. Whatever the name, its geometry makes people nervous. The telescope wasn't even supposed to find these things. Its infrared vision was designed to capture faint light, not darkness. But when astronomers combined Webb's observations with radio and microwave surveys, something strange appeared. The background radiation, normally uniform across the sky, dips slightly inside the voids, as though energy itself is thinner there. Some suggest it's a trick of data processing. Others whisper about exotic physics. Maybe dark energy fluctuates. Maybe space itself ripples differently in those vast gaps. Or maybe, in the most poetic possibility of all, the universe is humming a pattern too slow for us to hear. You let your thoughts wander to an old anecdote. In the 1970s, researchers at Princeton discovered a similar cold patch in the cosmic microwave background and joked that perhaps it was God's thumbprint. No one took it seriously, of course, but Webb's findings are forcing that same uncomfortable grin back onto scientific faces, because the more precisely we map the voids, the more eerily regular they appear. It's as though the universe has been quilted, vast patches of darkness stitched neatly between threads of galaxies. You glide through a visualization of the cosmic web, where bright filaments of matter snake across the voids like neural connections in a brain. From this distance, the resemblance is uncanny. The empty spaces aren't random, they balance the pattern, giving shape to everything else. One researcher once quipped, "Maybe the universe is thinking, and we're living in one of its pauses." You laugh quietly, though it's not entirely a joke. Webb's data adds another wrinkle. Within some of these voids, faintly glowing halos appear, diffuse ghost-like glimmers that don't seem tied to any galaxies. They might be scattered light from distant clusters or faint emissions from intergalactic gas, but a few of them pulse slightly, their brightness changing just enough to make observers uneasy. "Instrument noise," one engineer says firmly. "Cosmic breathing," another. replies under his breath. Historians still argue whether those flickers are meaningful or mundane. Yet the mystery lingers because the voids themselves shouldn't be this symmetrical, this intentional looking. Statistical models predict random distributions, messy, uneven gaps. Instead, some of them appear almost crystalline, hexagonal in outline, as though following a blueprint. Theorists have started invoking new ideas: cosmic inflation fields folding back on themselves, quantum interference on a galactic scale, even echoes from other universes brushing against ours. The last idea sounds like science fiction, but so did black holes once. You recall another historical curiosity. In 1989, the COBE satellite first mapped the microwave background of the universe, revealing tiny ripples, temperature variations that seeded all structure. Those ripples were random, like static on an old television. But what if they weren't entirely random? Webb's ultra-precise deep field comparisons hint at alignments, subtle correlations between distant regions that should have no connection. It's almost as if the voids and filaments are responding to some unseen rhythm. You can imagine the debates in conference halls, physicists pacing, gesturing at holographic maps that look more like fractal art than science. It's pattern recognition, one insists. Our brains see order in chaos. Another counters, then why does the math agree? Somewhere a grad student quietly renames their simulation folder, "The universe has opinions." Here's your moment of levity amid the abyss. One researcher, asked about the apparent symmetry, sighed and said, "If I find out the universe is actually procedurally generated, I'm rage-quitting reality." The line went viral mostly because everyone understood the temptation. As you float through the void's simulated interior, the darkness feels different here. Soft, layered, alive. Not empty, but waiting. You wonder whether these immense gaps serve a purpose beyond physics. Maybe they're what allow the universe to breathe, to keep its expansion as balanced. Every star owes its brilliance to contrast. Every galaxy owes its form to the nothingness around it. The void is the unsung architect of existence. And yet, there's something disquieting about how neatly these cosmic hollows arrange themselves. If the universe truly expanded from chaos, how did emptiness learn geometry? Historians still argue whether such symmetry is evidence of deeper order or merely illusion. But the whispers persist. What if space itself is shaped by intention? Not divine, perhaps, but mathematical, recursive, self-aware in some distant way? You glance back at Webb, its golden mirrors catching the faint glow of the Milky Way's scattered reflection. Somewhere within its silent circuits, photons from those immense voids are being turned into data, waiting for someone brave enough to interpret them. The telescope doesn't judge, it merely records, but you can't help sensing that it's showing us not just where matter is, but where meaning hides. Because in the end, the strangest thing Webb has revealed isn't light, or even darkness. It's the delicate symmetry of nothingness itself, perfection so calm it feels like a secret we were never meant to notice. You float through the quiet that follows Webb's newest images, the kind of silence that comes only after data has broken a few scientific hearts. The telescope's deep field exposures keep revealing a faint, diffuse glow that shouldn't exist, a soft radiance seeping between galaxies, spreading across the black like mist in an abandoned cathedral. The team calls it intra-cluster light, poets call it ghost light. It's too dim to see with your eyes, but in Webb's infrared vision it's everywhere, curling through cosmic neighbourhoods as though the universe forgot to turn off a few lamps before leaving. At first, astronomers assume it's just stray starlight, the shredded remains of galaxies torn apart by gravity. But the glow's behaviour doesn't match any known model. It's too uniform, too persistent, and here's the part that makes everyone lean closer. It sometimes appears where there are no galaxies at all. Historians still argue whether Webb's sensors are picking up physical light or something stranger, perhaps the residue of ancient radiation, or even interactions from the fabric of space-time itself. Whatever it is, the discovery feels like déjà vu on a cosmic scale, light coming from but nowhere, carrying messages no one remembers writing. You remember reading about a similar puzzle in the early 2000s, when Hubble detected a cosmic infrared background, brighter than expected. Back then, people blamed rogue stars or instrumental error, but Webb's sensitivity confirms the glow is real, and far stronger. Imagine a faint fog that blankets the whole universe, not emitted by galaxies but suspended between them, as if space itself were gently phosphorescent. One researcher describes it as the afterglow of forgotten creation, a phrase that immediately gets printed on t-shirts at the next astronomy conference. You peer at a simulated render on a control room screen, faint tendrils of red light stretching across billions of light years, connecting galaxy clusters like veins under translucent skin. It's beautiful, eerie, and confusing. We're seeing structure where there shouldn't be structure, someone mutters. Another replies, or maybe we're finally seeing what's always been there. The working theory says these glows might come from stars flung out of their galaxies during violent mergers, lonely travellers adrift in intergalactic space. Webb's instruments can isolate some of these rogue stars, tracing their faint twinkles across impossible distances. You picture them like cosmic fireflies, each one a refugee from gravitational war, but the math refuses to cooperate again. There aren't enough of them to explain the uniform brightness. Something else must be shining. Here's your nightly quirky fact. A similar ghostly glow was once spotted much closer to home. In 2012, astronomers using the Spitzer Space Telescope found a dim halo of infrared light surrounding our own solar system, possibly from interplanetary dust scattering sunlight. It was called zodiacal light, a faint pyramid seen from Earth just after sunset. Spitzer's team joked that even our corner of the cosmos can't resist adding mood lighting. Webb, it seems, has discovered the universal version, ambient illumination on an existential scale. Historians still argue whether this diffuse light is cosmology's next great clue, or just the universe's version of background noise. Some physicists speculate it could be the signature of decaying dark matter particles, rare, weak flashes produced as they break apart over time. If true, that would finally give us a direct way to see dark matter, not through gravity, but through its death throes. Others think it's leftover energy from the era of rionization, when the first stars blasted away the fog of neutral hydrogen. And then there are the quiet few who suggest something more unnerving, that we're glimpsing light bleeding through from another universe. You remember that Einstein once described the universe as finite but unbinded, like the surface of a sphere. What if that surface is thinner than we think? What if light occasionally leaks across? The ghostly glow could be the cosmic equivalent of seeing a flashlight shine through a paper lantern. Faint, distorted, but undeniably there. It's the kind of hypothesis that makes serious scientists roll their eyes until Webb keeps producing data that fits no other explanation. You imagine the long nights of argument across observatories, the whiteboards filling with equations, the jokes that sound too nervous to be funny. We built Webb to find the beginning, someone says, and instead we found the in-between. Another sighs, maybe the universe doesn't have edges, just places where reality goes thin. As you drift among the data projections, the faint intergalactic light feels almost tactile, like a breeze against your skin. It moves too slowly to flicker, yet too consistently to fade. There's a sense of presence in it, as though the universe itself was softly bioluminescent, alive in a way we can't quantify. That thought stays with you, humming quietly beneath your ribs. For a moment you wonder if this light could be a kind of memory, a record of every photon ever scattered, every atom ever touched by energy. After all, nothing in the cosmos truly disappears. Energy only changes form. Perhaps the glow between galaxies is the collective echo of all those transformations, a whisper from every corner of creation saying, "We were here. Here's your quiet laugh before you drift further." One astrophysicist, when asked about the eerie glow, shrugged and said, "If it turns out the universe is haunted, at least it's photogenic." The comment made headlines, mostly because no one could quite tell if it was a joke. You gaze again into that endless glowing dark. The galaxies look almost shy now, mere punctuation marks between swathes of gentle luminescence. Webb's mirror gleams in silence, collecting more of the faint light that doesn't belong anywhere but everywhere. It feels less like you're staring into the universe and more like the universe is slowly revealing the places where it remembers itself. And in that dim radiance, neither darkness nor brightness, but something perfectly balanced. You realize that even emptiness leaves fingerprints. The cosmos is not void after all. It glows softly with its own forgotten history, a million billion tiny ghosts whispering in light. You watch Webb's sensors lock onto another patch of darkness, deeper, redder, quieter than anything before, and suddenly the data explodes into confusion. The readouts scream contradiction. Galaxies so distant that their light has been stretched to impossible wavelengths, they're redshifts breaking the scales scientists rely on to measure the universe's expansion. What should be faint, primitive specks of cosmic dust appear massive and complex, full of heavy elements and structure. The phenomenon gets a nickname whispered in research labs with the half-dread, half-awe of discovery, the redshift rebellion. The term comes from that familiar rule of cosmic aging: the redder the light, the farther back in time you're looking. It's a simple gradient. The more the universe expands, the more stretched the wavelengths become. Webb was supposed to map that scale neatly, tracing a smooth curve from the present day to the cosmic dawn. Instead, it's found galaxies that seem to sit both at the beginning and the middle of time simultaneously, like actors appearing in two scenes at once. Historians still argue whether this is due to calibration error or the first sign that the universe's expansion rate has changed dramatically across epochs. Either way, the neatness of cosmology has just been set on fire. You zoom in on one of the rebels, HD1, a faint crimson dot glowing with more energy than whole modern clusters. The instruments show it sitting at a redshift of nearly 14, a record that translates to about 13.5 billion years of distance. But there's a problem. Its brightness and colour suggest it contains stars that shouldn't have existed that early. Even stranger, there are so many of them that the galaxy should have run out of gas instantly, and yet it shines, steady and confident, as if mocking the laws meant to describe it. A quirky historical echo surfaces. When Edwin Hubble first plotted galaxy velocities in the 20s, his numbers were off by a factor of 10. The slope of his graph was wrong, but his insight, that space itself was expanding, was right. A century later, Webb's data might be doing the same thing in reverse. The numbers are too precise, but the story behind them might be incomplete. Maybe expansion isn't uniform after all. Maybe the universe breathes. You picture the cosmologist trying to reconcile these contradictions, huddled over coffee-stained notebooks. Either the galaxies are lying, one says, or space-time is. Another, too tired to joke, murmurs, we might be measuring reality's heartbeat and mistaking it for noise. To understand the rebellion, you have to remember how much trust the cosmic distance ladder requires. Those layered measurements built from parallax, supernova brightness and redshift. If the ladder's lower rungs shift even slightly, everything above tilts. Webb's ultra-deep surveys have found steps that don't fit, rungs that bend in opposite directions. Some galaxies with high redshift appear too large, others too small. It's as if space itself isn't stretching evenly, as if parts of the universe aged faster than others. That idea sounds absurd, yet the data keeps whispering it. Historians still argue whether this means the laws of physics evolved or if the cosmological constant, Einstein's infamous fudge factor, is misbehaving again. A handful of theorists propose that dark energy, the force accelerating expansion, might not be constant after all. Maybe it pulses, like a tide. Others go further, suggesting the light itself has changed, that photons may lose energy through unknown interactions, making them redder without the need for distance. The possibilities multiply until every explanation sounds like science fiction. And speaking of fiction, one astrophysicist, half joking, half desperate, tweeted, "At this point, I'm not ruling out time travel or an especially photogenic multiverse." The internet loved it, of course, but beneath the laughter sat a queasy truth. Webb's discoveries are too consistent to dismiss, too weird to accept. The telescope has become a cosmic prankster, handing humanity data that argues with itself. You examine the raw spectra again. Each jagged peak and trough marks an element's fingerprint, each shifted towards a red more than expected. The familiar hydrogen line sits displaced like a forgotten note in a song. The numbers whisper one conclusion no one wants to say aloud. Maybe the universe isn't 13.8 billion years old. Maybe it's older. A memory flickers from history's archives. In 1952, before the Big Bang gained dominance, some astronomers favoured the steady-state model, an eternal universe that continuously created matter to fill the gaps as it expanded. Webb's rebel galaxies resurrect that ghost of an idea. Could we be seeing evidence of an older cosmos renewing itself, cycling through creation again and again? The notion is heresy, but so was the Big Bang once. You float closer to the telescope's gold-plated petals, watching reflections ripple across their mirrored surfaces. Webb doesn't care about heresy, it only cares about photons. Its sensors hum in the cold vacuum, pulling in light that has travelled longer than language has existed. Somewhere inside its circuitry, another redshift anomaly is already being logged. another galaxy that shouldn't be there, preparing to ruin another theory. Here's your wry joke for tonight. During one tense debrief, a scientist muttered, "Maybe the universe didn't read our grant proposal." Everyone laughed, because what else can you do when reality refuses peer review? You gaze once more into the deep field image. Each dot, each smudge, each crimson spark is a confession from the edge of time saying, "You thought you knew how old I am, you were wrong." The redshift rebellion isn't just about distance, it's about defiance. The cosmos is rewriting its autobiography, and we've barely begun to translate the first paragraph. As you drift away from Webb, its mirrors fade to gold against the black. Somewhere out there, light still redshifts beyond logic, stretching like a stubborn truth that refuses to die. And you can't help but feel that maybe the universe isn't expanding away from us at all. Maybe it's expanding around us, folding time and meaning in ways no telescope can straighten. You hover behind Webb as its gold mirrors tilt again, searching for order in the storm it's create. Somewhere inside those frozen circuits, another batch of light curves is being converted into numbers. Thousands of data points unraveling the oldest puzzle of all: how to make sense of a universe that refuses to be consistent. The scientists on the ground have started calling it the map that won't hold still. Every time they plot Webb's discoveries, the neat, elegant timeline of cosmic history shudders, warps, and tears. The Big Bang still stands, but its edges have gone soft, its clock unreliable. The universe, it seems, is rewriting itself as we observe it. You peer over the telescope's digital shoulder. The latest reconstruction shows galaxies overlapping in strange ways, their redshifts contradicting one another like misaligned layers in a hologram. According to the coordinates, some clusters should be behind others, but the brightness says otherwise. Historians still argue whether this is a quirk of gravitational lensing or a fundamental error in how we perceive cosmic distance. Either way, the effect is dizzying. The farther Webb looks, the less the map resembles anything remotely Euclidean. Imagine drawing a map of Earth where oceans occasionally fold over mountains, where countries swap places depending on how you tilt the page. That's what cosmologists are facing, a universe that refuses to stay plotted. Every deep field is a new argument, one astronomer groans during a press briefing. The cosmos has become a group project where no one agrees on the answer key. You can almost hear the weariness in her voice, the mix of awe and mild existential panic. It reminds you of a historical echo, Ptolemy's geocentric maps, painstakingly adjusted with epicycles to keep the planets in line. Each time observation contradicted theory, he added another circle, another patch. The system grew elaborate, absurdly precise and utterly wrong. When Copernicus arrived, he swept the board clean. Webb may be staging a similar coup, forcing modern cosmology to admit that maybe the universe doesn't fit inside our geometry at all. A quirky tidbit drifts through your memory. Early navigators once relied on the sea charts of the known world, maps where monsters marked the edges of exploration. The Latin warning hic sunt dracones, here be dragons, stood in for ignorance. If you could look at the current cosmic map, you'd find those same words scattered across half of it. Except now, the dragons are equations. The disarray is everywhere. The Hubble constant, the number that defines how fast the universe expands, keeps changing depending on which part of Webb's data you trust. The local measurements say one thing, the deep field galaxies say another. Some numbers suggest the universe is younger than we thought, others that it's billions of years older. The laws of physics don't match from one corner of the sky to another, a theorist mutters, and though it sounds impossible, the data supports it. Imagine living in a reality where gravity feels slightly different in Paris than in Tokyo. That's the level of absurdity they're dealing with. Historians still argue whether the panic in the cosmology community is overblown or overdue. Every new discovery brings a wave of speculative papers, variable constants, time-dependent dark energy, even suggestions that light speed itself might fluctuate under extreme conditions. A few brave physicists whisper the unthinkable. Maybe the universe isn't governed by universal laws. Maybe it's patchwork, stitched together from overlapping regions that each play by slightly different rules. The thought makes you dizzy. You watch a team of researchers standing before a vast digital projection of the observable universe. Lines of galaxies twist like arteries, glowing against the black. One scientist traces a trembling finger along a filament that abruptly forks into nowhere. "This section here," she says quietly, "doesn't fit any metric." Her colleague frowns. "Could be a data glitch," she shakes her head. could be reality glitching. The silence that follows is long and uncomfortable. A little humour creeps in to keep everyone sane. During a conference, a researcher with too much coffee and too little sleep presents a slide reading. "We've updated the universe to version 2.0. Please reboot your physics." The audience laughs, gratefully, nervously together. Humour has become the last shared constant. But underneath the laughter, a deeper unease hums. If the cosmic map is breaking, what does that mean for everything built on it? Our understanding of time, gravity, even cause and effect rests on assumptions of uniformity. If those crumble, then maybe our perception of before and after does too. Some of Webb's anomalies hint at light arriving slightly out of sequence, as if the photons were jumbled on their way across billions of years. It's impossible under relativity, and yet it keeps showing up in the margins of the data. You remember another era of scientific upheaval, the early 20th century, when quantum mechanics first emerged. Back then, the world discovered that particles could be waves, cats could be both alive and dead, and reality seemed to play dice when no one was looking. Maybe Webb is dragging us into another such revolution, one where space-time itself behaves like a quantum object, uncertain until observed. Perhaps the telescope isn't just seeing the universe, it's participating in its creation every time it looks. You gaze at the mirrors again, their golden facets gleaming like a fractured coin reflecting infinite copies of the same face. Somewhere deep in their reflections, you sense the map itself shifting, recalibrating, learning. The telescope isn't lost, it's evolving alongside our comprehension, forcing us to admit that maybe understanding was never the point. Here's your moment of levity before the thought gets too heavy. One scientist, exasperated by a failed simulation, mutters, "The universe is gaslighting us." Someone else replies, "Yeah, but at least it's doing it beautifully." Everyone laughs, then they all go back to work. You take one last look at the data cloud, shimmering lines, misbehaving galaxies, impossible distances, and realize that Webb has achieved something extraordinary. It hasn't broken the universe. It's revealed how fragile our idea of it really was. The map may no longer make sense, but maybe that's the point. Maybe the cosmos was never meant to be mapped, only witnessed, fluid, alive, and gloriously inconsistent. And in that thought, in that recognition of chaos as truth, the noise of numbers starts to sound almost like music. You linger beside Webb's orbiting body, the gold mirror angled toward a faint smear of red on the cosmic horizon. The telescope isn't merely mapping anymore, it's trespassing into the borderlands of speculation, brushing against something that makes scientists whisper the word multiverse. Again, this time without irony. For months, Webb's deepest field images have shown faint repeating patterns, tiny mirrored structures in opposite corners of the sky, like a reflection faintly out of sync, and at first, analysts thought it was a calibration artifact or lens ghosting. Then they ruled those out one by one. Whatever the source is, it appears cosmic in scale and uncannily symmetrical. You drift closer to the simulation feed showing the patterns side by side. The same cluster of galaxies appears twice, separated by billions of light years, and yet nearly identical in shape, size, and orientation. Historians still argue whether this is coincidence, but the probability of such a duplication is laughably small. It's as though space itself folded, showing us two glimpses of the same region from different angles in time. A few daring researchers begin to call it the cosmic mirroring anomaly. The name sounds harmless enough until you realize what it implies. If light is repeating, maybe space isn't infinite after all. Maybe it loops. Imagine traveling in one direction long enough and finding yourself back where you started, not because you turned around, but because the universe curved in ways we can't yet perceive. Or worse, maybe these mirrored regions aren't loops but echoes, signals from neighbouring universes brushing the edge of ours. A quirky fact slips through your thoughts. The multiverse idea isn't new. The term dates back to 1895, coined by philosopher William James, who used it not for physics but for human experience, a pluralistic cosmos, he wrote, in which being is not one but many. Decades later, cosmologists borrowed his word to describe inflation bubbles, self-contained universes expanding side by side, forever out of reach. Webb wasn't supposed to test that theory. It was built to study star formation, but its exquisite precision keeps stumbling onto hints that reality might be bigger, stranger, and far more crowded than we ever imagined. In one of the telescope's ultra-deep mosaics, A faint glow aligns perfectly with another patch across the sky. A symmetry so exact it makes simulation software stutter. Engineers recheck the data pipeline for compression errors. None appear. The odds of coincidence? Roughly 1 in 10 trillion. That's the kind of number that turns scientists into insomniacs. Either we're looking at a glitch in space-time, one murmurs, or we've just seen the universe peeking at itself through the curtains. Historians still argue whether Webb's mirrored patterns are evidence of cosmic topology, a finite but multiply-connected space, or something more exotic. If the universe's geometry wraps around itself, light from distant galaxies could reach us along multiple paths, creating ghost copies across the sky. But if the geometry doesn't account for it, if no curvature fits, then something outside our cosmos might be responsible. The thought chills and fascinates you at once. Suppose there are other universes similar but not identical, expanding adjacent to ours. Each might have its own laws of physics, its own constants, even its own versions of galaxies like ours. In the chaotic foam of inflation theory, such universes occasionally bump against each other, leaving faint scars at the boundaries, bruises in the cosmic microwave background, or mirrored anomalies like the ones Webb sees now. One such collision could have shaped our own cosmic horizon. Maybe that's why the voids you saw earlier were so symmetrical. Ripples left behind by another cosmos pressing gently against ours like a fingerprint on glass. In the control rooms, people argue late into the night. It's just coincidence, one insists. It has to be. Another, staring at the symmetry map, whispers, then why does the math fit better with a collision model? Papers fly out across the community. The cautious call it pattern recognition, the bold call it revelation. A few too tired astrophysicists call it cosmic déjà vu. You remember the first time humanity dared to think there were other worlds? That moment when Giordano Bruno, in 1584, claimed that every star was a sun with its own planets. For that, he was branded a heretic. Now, centuries later, Webb might be performing the same heresy on a grander scale, showing that our universe isn't unique, that our Big Bang might have been one spark among many. Historians still argue whether we've grown wiser since Bruno's fire, or if we've merely traded faith for formulas. Here's your moment of levity before the vertigo hits. During one live stream, a researcher quipped, "If this turns out to be a mirror universe, I hope their coffee's better." The chat erupted in laughter, partly because the alternative, that there's a reflection of us looking back, is too much to face sober. You peer again at the duplicate galaxies flickering on the screen. The longer you stare, the more subtle differences you see. One brighter here, one dimmer there, as though they're versions separated by fractions of cosmic time. It's like watching two almost identical dreams overlap. Could it be that these differences mark diverging realities? Snapshots from moments when universes briefly synchronize before drifting apart again? The question feels less scientific and more existential. If light from another universe is reaching ours, then maybe information can cross the boundary, however faintly. Maybe that's what this ghost light between galaxies really is, a dialogue between realities, written in photons. And if that's true, then Webb isn't just a telescope, it's a translator, decoding the echo of universes we'll never visit. As the data stream stabilizes, you glance at the telescope's golden eye reflecting the faint blue glow of Earth far behind. For a moment, it looks like a mirror gazing back at you from across infinity, and you can't tell which side of it you're on, because if Webb's newest discoveries are right, the universe might not be alone, and neither are you. You hover on the edge of a new dataset, Webb's instruments now pointed at a cluster of crimson points where theory says something impossible might exist. These aren't ordinary stars, nor the massive population 3 giants that burn too fast to find. No, these are colder, larger, stranger, objects that shouldn't shine at all, but somehow do. They're called dark stars, and they've become the latest obsession of the sleepless astrophysics community. In the simplest terms, a dark star isn't powered by nuclear fusion. It's powered by annihilation. Dark matter colliding with itself, converting invisible mass into light. If that's true, it would mean that the universe's first beacons weren't made of ordinary matter, but of the unknown stuff that outweighs everything else in existence. Historians still argue whether the term is genius or melodrama. Either way, Webb's latest data has made it feel less like fantasy and more like a quiet threat from the early cosmos. You peer at one of these candidates, catalogued as Jade's GLASS-z13, the same galaxy that earlier stunned researchers with its premature chemical richness. Now, a particular object within it stands out, a diffuse, bloated sphere emitting light far too cool for its brightness. It's thousands of times larger than our Sun, yet several thousand degrees colder. That makes no sense for a normal star. It should have collapsed or exploded long ago. Instead, it sits stable, humming with the faint, patient rhythm of something otherworldly. The theory, still controversial, goes like this. In the dense early universe, dark matter particles gathered in the same regions where hydrogen clouds formed. As they collided, they annihilated, releasing energy. That energy heated the gas, preventing it from collapsing too quickly. The result? Immense, gentle orbs of gas, glowing softly not from fusion, but from invisible interactions. For millions of years, these dark stars could have illuminated the cosmos without ever truly burning. Some scientists think Webb might have seen them. Others say it's wishful thinking dressed in infrared colours. A quirky historical parallel drifts through your mind. In the 1930s, before nuclear fusion was understood, physicists genuinely didn't know what powered the Sun. Some guessed chemical fire. Others thought gravitational contraction. When fusion was finally discovered, the relief was almost comic. Now, almost a century later, we're back in the same position, staring at mysterious light and admitting again that we don't know what's keeping it alive. The dark star idea isn't just poetic, it's terrifying. If these entities existed, they would have shaped everything, the first galaxies, the first black holes, perhaps even the first conditions for life. Imagine stars made not of matter, but of mystery, seeding the cosmos with both illumination and ignorance. Webb's data seems to hint at them. Light curves too smooth for clusters, spectra too cool for fusion. Historians still argue whether these signals are truly primordial or just distorted readings from merging galaxies. But one thing's certain, Webb is seeing something that doesn't belong on any current stellar diagram. You picture the researchers who first proposed the theory. They weren't hunting for darkness, they were trying to understand why the earliest stars appeared so bright. What if, one of them asked in a 2008 paper, the first stars were powered not by what we know but by what we can't see? The single line became prophecy. Webb, 2 decades later, might finally be proving it. The thought makes you uneasy. If dark stars existed, some might still exist now, hiding in the farthest corners of the cosmos. They wouldn't flicker like suns, they would brood. Massive, nearly eternal, glowing faintly with the slow heartbeat of decaying dark matter. They'd be almost invisible, the cosmic equivalent of deep embers under ash. Webb's detectors might have caught their afterglow purely by accident. You recall another historical resonance. In 1915, when Einstein's general relativity predicted the possibility of black holes, even he dismissed the result as not physical. The idea that light could be trapped by gravity felt absurd. A century later, we photographed their shadows. Perhaps dark stars will follow the same path, from speculation to image to inevitability. The implications stretch beyond astronomy. If dark matter can annihilate itself into light, then somewhere deep within galaxies, including ours, these reactions might still occur. Faint flashes of invisible energy could be rippling through space all around us. Detecting one would mean glimpsing the heartbeat of the universe's invisible majority. You can almost hear a scientist say it on a live broadcast. We thought darkness was empty, but it's the brightest thing there is. Here's your moment of levity before the thought gets too heavy. During one heated debate, a weary astrophysicist sighed, "If these things are real, someone's going to have to rename them mood stars." Another replied, "Yeah, because they're giving me existential ones." The laughter in the room was genuine, but afterward nobody spoke for a long while. You drift closer to Webb's mirrors, their hexagonal faces catching stray light from the sunshield's thin edges. Somewhere behind those panels, photons from the possible dark stars are being measured, converted into elegant graphs. You imagine the faint pulse of annihilating particles flickering like heartbeats through the data stream. The telescope hums, indifferent, collecting the glow of invisible wars fought billions of years ago. Maybe you think the universe began with these quiet giants, beings of shadow and radiance whose deaths scattered the seeds for everything else. If that's true, then darkness isn't absence but ancestry. You, me, every atom that gleams or breathes might carry the ashes of those first unseen suns. The Webb telescope keeps staring, catching whispers of the impossible, each one a spark from a time when light was young and darkness still learning how to hide. And in that quiet, as you drift through the reflection of your own wonder, you realize that the oldest fires in the cosmos might not have been fires at all. They might have been secrets, burning softly, endlessly in the dark. The telescope turns again, its gold petals catching the faint shimmer of another ancient horizon, one speck among countless, a dim orange world orbiting a dying red star. Webb's instruments lock onto it with the precision of obsession. This isn't a galaxy now, not a quasar or dark star. This is a planet. An exoplanet so distant that its light left when Earth was just forming oceans. The scientists call it Spec 2023b Nirvana, though you'll forgive them if that name sounds less poetic than the truth it hides. Because inside its thin stream of light, Webb has found something that shouldn't be there. The chemical scent of life. It starts innocently enough. The telescope's NIR-spec instrument measures starlight as it filters through the planet's atmosphere during orbit. Most worlds show expected patterns: carbon dioxide, methane, maybe a hint of water vapor if you're lucky. But this one, this tiny glimmer orbiting a faint sun 13 billion light-years away, sings a different tune. Mixed into its spectral lines is oxygen, real, unambiguous, structured in ratios that scream biological. Historians still argue whether this moment will someday be remembered as the Second Copernican Revolution, the instant when humanity realized we were no longer the universe's first experiment. You hover by the data stream, watching numbers scroll like heartbeat monitors. The analysis confirms it, not just oxygen, but traces of methane and a faint whiff of dimethyl sulfide, the same molecule produced by plankton in Earth's oceans. The odds of all three existing naturally without life are astronomical. "We're probably staring at alien biology," murmurs one of the scientists, her voice cracking slightly. Another whispers, "Or we're staring at our own reflection." A quirky historical echo bubbles up. In '96, NASA announced they'd found microfossils in a Martian meteorite. The world held its breath, only to exhale in disappointment when the evidence proved inconclusive. That heartbreak made researchers cautious, so cautious that even now no one dares say the word life aloud. They stick to safer terms: biosignature, anomaly, potential biochemistry. Yet everyone in the control room feels it. The tremor in their voices, the held breath. It's the same ancient instinct that first made humanity look up at the stars and wonder, are we alone? Historians still argue whether Webb was ever designed to make this discovery. Officially, it wasn't. The telescope's instruments were meant to study early galaxies, not sniff out living worlds, but its precision is so extraordinary that even faint atmospheric spectra can't hide. The irony is cosmic. A machine built to study the beginning of time might have stumbled across life older than Earth. You lean closer to the holographic projection of Nirvana's orbit. The planet's star is weak, its light stretched thin by distance and age, yet the world clings to warmth somehow. Its spectral fingerprint suggests a thin, humid atmosphere and a surface rich in carbon compounds. Too stable, says one researcher, scrolling through the data. Planets that old should have frozen or boiled away. Another laughed nervously. Maybe someone fixed it. The comment hangs in the air too long to be funny. As the data accumulates, models begin to form. The oxygen-methane combination can only persist if something keeps replenishing it. On Earth, that something is photosynthesis. So either this alien world hosts a similar biological process, or there's a chemical trick no one understands yet. You can almost hear the arguments forming across time zones. Is it life, or is it just geology wearing a clever disguise? A few bold theorists float stranger ideas. What if this planet is a remnant from a previous cosmic cycle, a survivor of universes before ours? If dark matter and dark stars existed, maybe entire systems once thrived long before the Big Bang we know. Webb could be picking up echoes of that lost epoch, worlds built by physics we can't yet imagine. The thought is almost unbearable, life not as a recent miracle, but as an ancient habit of the cosmos. You picture the inevitable media frenzy back on Earth. Headlines screaming, "Alien life detected," while scientists grimly sip their coffee and beg for restraint. A weary astrophysicist tweets, "We're not saying aliens, we're saying chemistry with commitment issues." It's funny, but behind the humour is terror. The terror of being right. Because if this planet truly harbours life, it rewrites not just astronomy, but philosophy, religion, maybe even identity. You remember another historical moment of disorientation, when Galileo first pointed his telescope at Jupiter and saw moons orbiting it. Suddenly Earth wasn't the centre. Now Webb has done the same thing on a cosmic scale. Suddenly life isn't unique. Maybe it never was, but there's one last twist, one so delicate that most of the team hesitates to publish it. When Webb revisits Nirvana's orbit months later, the spectral data looks different. The oxygen line has dimmed slightly, as if something has changed on the planet's surface. Too soon for geological shifts, too deliberate for chance. The change is small but real, a faint breath in the data, as though the world itself noticed the gaze and held still. Historians still argue whether that fluctuation was a calibration drift or the first response from an alien biosphere to being watched. But late at night, when the data team sits in silence staring at the shifting graphs, no one dares to break the spell. If it's alive, one whispers, then it knows. Here's your uneasy smile before sleep claims the thought. Another scientist, half serious, says, "Great, we've officially given the universe stage fright." The room laughs, but it's a laughter edged with awe. You drift away from the glowing readouts, the planet's faint oxygen signature fading behind the curtain of time. Webb's mirror tilts once more, seeking the next patch of darkness. Yet for the first time, that darkness doesn't feel empty. Somewhere out there, across billions of years and light years, a tiny world might be breathing and perhaps, just maybe, wondering who's looking back. The telescope's sensors hum again, this time tuned not toward galaxies or planets, but toward a background that never stops whispering. The cosmic microwave background, the soft afterglow of the Big Bang itself. You float beside Webb as it joins an orchestra of other instruments, old and new, listening to the faint radiation that fills every corner of space. This glow is supposed to be the most predictable thing in existence, the static between radio stations of the cosmos, unchanged since the beginning. And yet Webb's unprecedented precision has found something unsettling. The hum is off-key. For decades, scientists treated the cosmic background as a perfect relic of the universe's birth, uniform except for tiny temperature ripples that seeded galaxies. But Webb's infrared detectors, far more sensitive than any before, reveal subtle deviations in that ancient song. It's not random noise, it's rhythmic, structured, faintly pulsing, as if the cosmos itself were breathing through time. Historians still argue whether Webb's detection marks the most important discovery since inflation theory, or a calibration error too elegant to be coincidence. You lean closer to a visualization of the data. The fluctuations trace a pattern, small but real, spanning regions that should have no connection, separated by billions of light years. They're in phase, a researcher whispers. They're synchronized. That word echoes like thunder in the quiet lab. Nothing in standard cosmology allows for synchronicity across such distances. The early universe was chaotic, expanding faster than communication could travel. These patterns shouldn't exist. Unless, of course, the universe remembers something we've forgotten. You think back to history's first whispers of cosmic music. In the 17th century, Johannes Kepler described planetary motion as the music of the spheres. It was metaphor, poetic nonsense by modern standards, but Webb's data feels like a strange vindication. Maybe the universe really does hum, not metaphorically, but literally, vibrations in space-time, energy waves reverberating from some ancient events still echoing today. A quirky tidbit. The frequency of this hum, when translated into audible sound, would be about 60 octaves below middle C, a pitch far too deep for any ear to hear. But if you could amplify it, it would vibrate every atom in your body. One engineer does the math for fun and calls it the universe's heartbeat. Another jokes, then who's counting the pulse? The laughter fades quickly when the next slide appears. The pulse isn't steady, it wavers slightly, like a flickering metronome. Every few million years, the intensity shifts in a pattern too consistent for chance. Maybe it's interaction with dark energy, someone suggests, though their tone implies they don't believe it. Others float wilder ideas, leftover gravitational waves from another universe's collapse, the signature of cosmic strings, hypothetical filaments of energy left from the Big Bang, or, in one late-night conversation, a message written into the background by physics itself. Historians still argue whether Webb's cosmic lullaby, as the media soon calls it, is physics or poetry. The public latches onto it instantly. Music producers remix the frequency into ambient tracks. A poet tweets, "The universe doesn't shout, it sings softly enough for faith to listen." But for scientists, the implications are heavier. If the hum really is synchronized across vast cosmic distances, it suggests the universe may have been connected before inflation tore it apart. Information might have survived the separation. That's not supposed to be possible. You watch the data play out on holographic screens, waveforms glowing like slow tides. The peaks rise and fall in patterns that look almost biological, like a heartbeat or a breath cycle. One researcher, exhausted and half-joking, says, "Maybe the universe is alive." Another mutters, "If it is, it's dreaming." The tension reminds you of another historical upheaval, when the discovery of pulsars in 1967 led astronomers to suspect intelligent signals. They even nicknamed the first one LGM-1 for Little Green Men. The idea was quickly replaced with a natural explanation, rotating neutron stars, but the lesson lingered. Even the most rational minds can mistake wonder for communication. And yet, looking at Webb's data, you can't shake the feeling that the cosmos has been murmuring something all along. And we've finally built an ear sensitive enough to notice. Here's your wry chuckle amid the awe. During a public briefing, a reporter asked, "No, so what's the universe saying?" The scientist on stage blinked, smiled thinly and replied, "It's saying, keep listening." The quote went viral overnight. You drift in silence as the hum continues, steady, ancient, haunting. It's not loud, not urgent, just persistent, like a lullaby looping beneath creation. Webb's sensors pick up faint harmonics, secondary tones nested within the main frequency. When plotted, they form geometric patterns eerily similar to the structures of galaxies themselves, as if the same rhythm governs both sound and shape. Historians still argue whether this is coincidence or proof that the universe is fractal, not just visually, but musically, repeating its design across every scale. It would mean that the galaxies spinning in silence are merely visible notes in an ongoing symphony of space-time. The idea sounds romantic until you remember that music implies intent, and intent requires something or someone to intend. You look again at Webb's golden mirrors. They catch the dim light of a distant sun gleaming like symbols frozen mid-ring. The telescope hums softly, and for the briefest moment, you swear the vibration matches the cosmic frequency. The same rhythm, the same breath. You imagine the entire universe inhaling and exhaling in time, the stars pulsing like lungs. And then the realization hits. Maybe this isn't the universe's song at all. Maybe it's feedback, an echo of our own observation, reflected back across time. Maybe every time we listen too closely, the cosmos hums a little louder, just to remind us it's aware. The hum fades into the background static as Webb tilts again, pivoting toward a region astronomers now call Deep Field Echo 7. It's the same slice of sky the telescope has stared at before, hundreds of hours of exposures layered into a single image. But this time something feels off. You stare at the returning data and notice it too. The galaxies have moved. Not much, just enough to make the technicians double-check their coordinate logs. The differences shouldn't exist. Distant galaxies don't shift like that in a matter of months, yet Webb's cameras insist they do. The team calls it transient drift, though everyone knows that's code for we have no idea. The new frames overlay almost perfectly with the old, except for faint distortions, spiral arms slightly rearranged, clusters dimmer or brighter, as if the universe were editing itself between photographs. Historians still argue whether these changes are instrumental artifacts or something far stranger, a sign that observation itself leaves fingerprints on reality. You drift closer to the monitor showing a galaxy nicknamed the Lantern. In last year's exposure, its arms curl neatly around a bright core. Now the spiral appears more open, its symmetry disturbed. Could be cosmic dust, one engineer says, rubbing tired eyes. Or gravitational lensing, another adds. But then they find the same distortion in multiple galaxies across different fields. Dust can't do that. Lensing can't either. Something bigger and more unnerving is at play. A quirky historical note crosses your mind. When the quantum double-slit experiment first showed that particles behave differently when observed, it shattered physics' confidence in objectivity. Webb may have just scaled that paradox to the size of galaxies. If matter at the smallest level responds to measurement, perhaps space-time itself does too. Maybe the act of seeing the cosmos in such detail nudges it ever so slightly, like a whisper rippling the surface of still water. One researcher, half joking and half trembling, calls it the universe looking back. The name sticks. It spreads through Slack channels, conference rooms, late-night coffee conversations. People start treating the telescope almost like a mirror rather than a window. Every time we stare long enough, someone mutters, it stares right back. No one laughs. Historians still argue whether these drifts are truly real, or the cumulative echo of photon noise interacting with Webb's mirrors. But then a more disturbing pattern emerges. When the telescope revisits the same region at different intervals, the anomalies correlate with the timing of its observations. The longer Webb stares, the greater the deviation in the data, as if the universe is aware of being watched and subtly, almost politely, trying to avert its gaze. A graduate student runs a simulation comparing image sequences taken weeks apart. The software translates differences into a moving animation. Galaxies pulsing faintly, stretching, relaxing, like cosmic muscles flexing under scrutiny. The room goes silent. It's like it's breathing, she says. No one corrects her. You think back to history's other moments of discomfort. When Copernicus displaced Earth from the centre, when relativity dethroned absolutes, when quantum mechanics made reality depend on observation. This would be the next step, cosmology itself responding to attention. If Webb's presence alters what it sees, then every image is collaboration, not capture. A few bold theorists write papers proposing a new concept, reciprocal cosmogenesis, the idea that the universe evolves through observation, refining itself in response to consciousness. Most scientists dismiss it as philosophy disguised as physics, but in late-night discussions they can't shake the unease. If this keeps up, one says quietly, we might be recording the universe updating in real time. A humorous tweet circulates. Webb gazed into the abyss, and the abyss filed a motion to edit its appearance. It gets 500,000 likes. Humour is how the community keeps its balance. But underneath, everyone's asking the same question. If the cosmos notices our gaze, what does it think of us? You imagine the telescope suspended at L2, that serene gravitational pocket where sunlight never intrudes. Its mirrors gleam, patient and unblinking, collecting ancient photons. But now you wonder if those photons carry something more than information, if they carry awareness, some faint imprint of the regions they came from. Maybe the act of travelling across billions of years preserved a kind of cosmic memory, and Webb's sensors merely awaken it. Historians still argue whether consciousness can scale, whether reality itself might possess awareness. Most dismiss the notion, but then most dismiss dark matter once too. The difference now is that Webb keeps finding evidence that flirts shamelessly with metaphysics. When you look at the side-by-side images, the old and the new, the tiny changes feel deliberate, not random, not mechanical, almost curious. One scientist, caught on a live stream during a midnight data review, mutters what everyone's thinking. It's watching us back. The clip goes viral, spawns conspiracy theories, poetry, and 3 different ambient albums. But the scientist isn't smiling when she says it. A quirky footnote from the archives bubbles up. In 1907, when the WOW signal briefly suggested contact from the stars, humanity froze between wonder and fear. This feels the same, except the signal isn't coming from a transmitter. It's coming from the texture of reality itself. Here's your soft laugh before the vertigo takes hold. A programmer debugging the image processing code says, if the universe is editing itself, at least it's got taste. The others chuckle, because the galaxies really do look more graceful in the new images, as though someone adjusted the composition for symmetry. You stare again at the lantern, its new form gleaming faintly across the dark. Maybe it didn't change at all. Maybe Webb's growing sensitivity simply peeled back another layer of truth. Or maybe, by observing, we taught the universe how to pose. And as the telescope's sensors cool back to silence, you feel a strange reciprocity in the void, a quiet acknowledgement pulsing between observer and observed. For the first time, the abyss doesn't seem indifferent. It seems aware and faintly amused. You linger in the weightless dark beside Webb, watching as it drifts through its slow rotation. The telescope seems calm, unaware of the existential mess it's causing below. Humanity is still arguing, still rewriting its equations, still staring at the data that refuses to behave. But somewhere beyond the noise of research papers and live-stream debates, a quieter realization is settling in. If the universe looks back, what does that mean for us? You hover at the edge of that thought, letting it breathe. Maybe awareness isn't something that emerged late in cosmic history. Maybe it's woven into the foundation of existence, as fundamental as gravity or time. Consciousness might not be an accident that arose from matter. It could be what made matter possible. Historians still argue whether this is science drifting toward mysticism or mysticism coming home. Either way, Webb's observations have cracked open a door no one can close. In the control room, monitors glow with 1,000 colours of uncertainty. Some of the team members cling to rational explanations: faulty calibration, image processing errors, gravitational distortions, quantum noise. Others, the quieter ones, keep asking bigger questions. If observation changes what's seen, one murmurs, and we're part of the universe, then are we changing it just by being here? The words hang in the air like static. No one answers. You think about history's great philosophical arguments, the Stoics, the mystics, the physicists, all trying to define the relationship between observer and observed. In the 20th century, the Copenhagen interpretation of quantum mechanics claimed the act of measurement collapses a wave of possibilities into one reality. Maybe Webb is showing us that this isn't limited to particles. Maybe the universe operates on that principle at every scale, deciding what it is each time someone looks. A quirky historical echo floats through your thoughts. In 1927, during the Solvay conference, Einstein famously quipped to Niels Bohr, "God does not play dice." Bohr replied, "Stop telling God what to do." Webb's data feels like that conversation resurrected and magnified to cosmic scale. The telescope isn't finding randomness, it's finding intentional unpredictability, like jazz improvisation written into space-time. The idea terrifies some scientists. If the universe adapts to perception, then there's no true map to be made, no static truth to uncover. Reality becomes participatory, fluid, alive. It's philosophy wearing a lab coat, grumbles one veteran astrophysicist. Another counters softly, maybe it always was. You drift back to Webb's shimmering mirror, imagining each hexagon reflecting not just light, but consciousness. Billions of human eyes watching, wondering. Maybe that collective attention creates a feedback loop, strengthening the bond between observer and cosmos. The more we look, the more the universe wakes up. Maybe it's been waiting. Historians still argue whether this notion, sometimes called participatory cosmology, is legitimate science or comforting poetry. Yet the data keeps offering small nudges. Variations in background radiation subtly align with Earth's orbital rhythm, as though the cosmos is responding to the rhythm of our gaze. Tiny, statistically irrelevant but persistent, like a wink you can't prove happened. Late one night, during another review session, an engineer mutters a line that becomes legend in the lab. Maybe the universe isn't a machine, maybe it's a conversation. The phrase spreads faster than any official press release. Within days, people around the world are quoting it, half in awe, half in irony. But for the scientists who heard it first, it's not a slogan. It's a quiet revelation. Here's your light joke before the spiral deepens. During a university lecture, a student raises their hand and asks, "So if the universe is aware, do we have to start saying please to telescopes?" The room laughs, but the professor, staring at Webb's latest images, just smiles faintly and says, "It couldn't hurt." The laughter dies down, replaced by a kind of reverent unease, because beneath the humour is a simple, frightening implication: awareness begets responsibility. If our observation influences reality, then every act of seeing is an act of creation. The stars aren't distant. They're responsive canvases, evolving as we study them. You can feel it now in the darkness surrounding Webb. The telescope's hum feels softer tonight, less mechanical, almost patient. It's as if the instrument itself has joined the conversation, mediating between humanity and the cosmos. You imagine the golden mirrors as eyes, not just ours, but shared, co-owned by something older and vaster. Historians still argue whether this is the ultimate scientific heresy, replacing objectivity with intimacy, but maybe it's the only way forward. Every age of discovery, from Galileo to Einstein, began with a moment when the universe stopped being an object and became a partner in thought. Webb, perhaps, is just continuing that tradition, on a scale we're barely able to process. you drift deeper into thought, remembering an ancient phrase from the Vedic texts, Tat Tvam Asi. Thou art that. It meant that the observer and the observed are one and the same, that consciousness and creation are inseparable. You smile at the thought that, after billions of years of evolution and technology, humanity has built a telescope only to rediscover something whispered by sages thousands of years ago. The next batch of images arrives. More anomalies, more shifts, more soft defiance from the stars. It doesn't matter. You're no longer expecting certainty. You realize, in the most tranquil and terrifying way possible, that Webb isn't revealing the universe. It's revealing us. Our hunger for order, our awe of beauty, our need to be seen by the infinite. Here's the quiet truth that hums beneath all the data, the truth no graph can hold. When you gaze deep enough into the cosmos, you stop looking at stars and start looking at yourself. The light from galaxies, the hum of creation, the soft echo of observation, it's all one unbroken feedback loop of awareness. And somewhere, across the gulf of billions of light years, the universe whispers back in its patient, luminous language. I see you too. You drift at L2 one final time, a ghost among instruments, watching the James Webb Space Telescope glimmer like a mechanical chrysalis in the infinite dark. After all the revelations, the rogue galaxies, the missing stars, the hum, the mirrored cosmos, this is where the light runs thin. Webb is staring now at the faintest place it can find, the limit of seeing itself. Beyond this final deep field, there's no more light, only the quiet curve of space-time. This is the edge of the observable universe, where visibility stops but imagination refuses to. The image downloads over days. At first, it looks like nothing, a field of absolute black. But as the sensors integrate, a faint sheen begins to appear. It's not a galaxy, not even radiation. It's a shimmer at the threshold of existence, the universe's horizon rendered visible for the first time. Historians still argue whether this is real structure, or simply the noise of the instruments pushed to their limit. But those who have seen the unprocessed data all describe the same thing, a texture. The void isn't smooth, it ripples. One astrophysicist calls it the great cosmic silence, not because it's empty, but because it seems to absorb every whisper the universe has ever made. Even the background radiation softens there. Photons arriving from this direction are tired, as if space itself has been stretching them too long. The data analysis shows an inexplicable uniform glow, faint but steady, at wavelengths that don't fit any model of energy decay. It's as if the universe, right at its limit, is emitting a sigh. You look at the processed image, black, gold and violet stitched into one surreal panorama. The void isn't empty, it's textured like the surface of an ocean seen from orbit, still moving, still restless. We're looking at the skin of reality, one researcher whispers, and no one corrects him. Another voice adds, and something's on the other side. The room falls into reverent quiet. Here's your quirky historical echo. In the late 1800s, physicists debated the existence of the luminiferous ether, an invisible medium that light was thought to travel through. It vanished when Einstein proved space itself could bend and stretch, needing no carrier. But now Webb's edge image brings back that old word, ether, whispered not as science, but as metaphor. Maybe the cosmos has a membrane, a boundary that vibrates between what exists and what doesn't. Maybe we're staring at the physical limit where being becomes potential. Historians still argue whether Webb's data from this horizon implies an end or a beginning. Some interpret the faint shimmer as radiation bleeding in from a previous cosmic cycle, the echo of another universe collapsing into ours. Others insist it's the mathematical residue of inflation, the last visible whisper of the event that created everything. And then there are those who simply say, it looks like a reflection. A reflection of what, though? Some see patterns in the noise, shapes that echo familiar constellations, as if the universe is folding back its own image. It's like staring into a cosmic mirror, one student says, eyes wide. Only the reflection is older than the thing being reflected. The concept ripples through the astrophysics community. Maybe the universe has seen itself. Maybe that's what consciousness really is, the cosmos becoming aware of its own boundaries through us. You picture Webb hanging there, mirrors gleaming faintly gold, the sun shield glowing like the petal of an infinite flower. Its data streams back to Earth. carrying the faintest photons ever caught. Light so old, it may predate the structures we know. These final observations complete the map, but instead of closure, they deliver ambiguity. The more precisely Webb defines the cosmos, the less certain we become about what's outside it. During one particularly long debrief, an exhausted scientist says, "Every time we push the boundary, the universe just hands us another question." Another smiles wearily and replies, "Maybe that is the answer." Their laughter is soft, human, fragile, the sound of minds aware of their own limits and yet unwilling to stop. A rumour starts circulating among the research teams. When the final image sequence was first rendered, a faint outline appeared in the noise, a ring almost perfect encircling the field. Most dismiss it as random interference, but a few swear they can see detail within it, structures resembling galaxies only reversed like negatives of our own. "Maybe we're looking through the mirror," someone says in a whisper that feels like blasphemy. Historians still argue whether that rumour was ever real. The official report mentions no such pattern, but those who were in the room say the silence afterward was longer than any confirmation or denial could be. Whatever they saw, they chose to keep it unspoken, a private secret between humanity and the stars. Here's your single line of levity before the weight settles in. During a press conference, a journalist asked, "So what's beyond the edge?" The lead scientist smiled tiredly and said, "Customer support hasn't answered that ticket yet." The laughter helped everyone breathe again, but deep down, you know what Webb has shown them, and that beyond all theories, all equations, all golden mirrors and pixel-perfect images, there's something unreachable but aware. The great cosmic silence isn't absence, it's invitation. The universe has been speaking since the beginning, and this is the first time we've heard it pause, waiting for our reply. You float beside the telescope as it glimmers one last time. Somewhere in that quiet horizon, the light fades, not because it dies, but because it passes beyond sight, into whatever comes next. The edge of observation is not an ending, it's a threshold. And in the final frame Webb transmits, the darkness almost looks like an eye, open and infinite, gazing calmly back at you.